Hi, this is Mr. Beck does your homework. This is AP Physics homework number 25 on rotational kinematics, and this is question number 11 and 12. It says, a car accelerates uniformly from rest, so I know that my initial angular velocity, omega zero, is going to be zero. It reaches a speed of 15.1 meters per second in 11.5 seconds. So that's actually a linear velocity of 15.1 meters per second. And then my elapsed time is 11.5 seconds. It says the diameter of a tire is 64.6 centimeters. That's a diameter. D is 64.6 centimeters. Interesting. Find the number of revolutions the tire makes during this motion, assuming no slipping. Answer in units of revolutions. Well, we've done something similar to this before, and let me make that my initial angular velocity as well. So let me go through this and just solve it in a linear fashion and then convert to revolutions, and so that we can figure that out. So what we have here is I have my distance traveled is going to be V0t plus 1/2 AT squared. That's not going to help me because what I have is with my initial velocity, my final velocity, and my time, if I'm looking for my distance, then what I could do is actually use my distance equals 1/2 of V0 plus V times T. That's going to be the easier way to solve it. So my distance is going to be half of my initial velocity of 0 plus my final velocity of 15.1 meters per second times the time of 11.5 seconds. And that's going to give me a displacement that's just, so that's just simple math. That'll give me a displacement in meters. Now, if the diameter is 64.6 centimeters, that's going to actually be a diameter of 0.646 meters. And I know that that's going to be twice the radius. And actually, if I want my circumference, actually my circumference is once around. So one revolution is going to be one circumference. And that's going to either be 2 pi times the radius, or it's going to be pi times the diameter. So I can use that one revolution is pi times the diameter, and I know my diameter there is 0.646 meters. So this is going to be number of meters. And so if I want my number of revolutions, what I can do is take the number of meters, which this is one revolution, is pi times the diameter in meters. And so that would give me my pi times 0.646 for me, 646. And then that would be one revolution. And so if I do that math, then meters is going to cancel out. And that's going to give me my theta in number of revolutions. That's going to be so many revolutions is going to be my angular displacement. So that would give me the number of revolutions for question number 11. Now, if I want the final rotational speed of the tire, well, this is actually simpler to get to. So since I have all of this, let's just take a look at the final angular speed of the tire in revolutions per second. Well, I know that I've got 15.1 meters per second is my final angular speed in the velocity. And so I know the relationship between my velocity and my angular velocity would be that my final velocity, that a velocity is going to be the angular velocity times the radius. And that's going to give me it in radians per second. But if I want my final angular velocity in revolutions per second, well, let's just do it the long way, just for practice. So here I've got my angular velocity of 15.1 meters per second. So let's write that here. I've got 15.1 meters per second. I know that there are 2 pi times the radius. 2 pi times the radius is going to be one revolution. And so in this case, the radius, this will be in meters, and that'll give me number of revolutions. So it's 15.1 meters per second, and this is revolutions, and that is my 2 pi times the radius. But remember, 2 times the radius is 0.646. So this could be 15.1 meters per second times one revolution is going to be pi times the diameter, or pi times 0.646. So this will allow me to calculate revolutions per second, because this is how many meters. Meters is going to cancel out, and this will give me revolutions per second. So it'll be 15.1 divided by pi, also divided by 0.646, will give me number of revolutions per second. And that will give me the answer to question number 12.